Hey, everybody. Yesterday, or last time, I guess I should say, instead of yesterday, we started these notes. One of the classes did a couple of these. One of us did not get to these. So I just want to real quick go over the second page of Unit 1, Lesson 6, Absolute Value Transformations. And then I will go over, obviously, the new lesson that we're doing for today. So just to zoom up here, what we're going to do is practice, I would probably call it the easy way. And I'm just going to open up our Desmos tab here. I am using the Chrome app to open up the College Board version. This is the version you'll be allowed to use on the SAT. So I just want to make sure we're practicing using that specific version. And what we're going to do here is just read the question. Example 1 says graph g of x equals the absolute value of x minus 3 and write the changes. And then it says f of x equals the absolute value of x is shown. So we're given the parent function. And then here, I'm just going to graph that. So I'm going to type in exactly how I see it on the paper. And here's a picture. And then I'm going to push the gear button and push the table, and that will give me a table of points so I can put it over here on my paper. And I'm just going to go ahead and graph these points exactly as we see them on the table. And I only have these that I can currently see. I do want to get to the edges of my table, so I'm going to go ahead and just click down here under the 2. And I'm just going to add in a couple larger values or smaller values if I'm going negative. So here I have negative 10, 7. I'm going to put that on the edge there. I'm going to pick one in the middle. I'm going to go negative 6, just so I kind of have an idea of where I'm drawing my line. There we go. And I'll do the same thing for the other side. So I'm going to look for positive 6 and positive 10. And that puts us here. And then just like we did during class, I'm going to use a highlighter to connect my dots so I can see where the dots are the whole time. And there we go, my little arrows at the end. And here is our new picture. You can tell pretty easily that our picture just slid down, right? It was here and it moved down a couple spots. Specifically, it looks like 3 spots. And you also could have figured that out. I'm going to scoot this over here. You also could have figured this out by looking at the actual equation. So the first thing I'm going to look at is just to mark H and K, and then A and B as well. So A would go here, B goes here in front of X, H is here, and K is here. You can see for this one, there's a lot of non-changes right here. Our A is 1, our B is 1, and our H is 0. And it looks the same right here. There's no other numbers on the front or on the inside. But there is a number on the outside. That was K. Originally, K was 0 because there was nothing back here. And now there is a minus 3. So our original vertex, which is H comma K, was 0 comma 0. And now it is at 0 comma negative 3. And you can see that here, right? The center point is the vertex. And now it is here at 0, negative 3. So the only change I can see is that we shifted down by 3 spots. And that's it. So what we're going to do is graph in the calculator, use the table to find the points and graph it on our paper. And then we're going to use the equation and the graph to identify what happened or what were the transformations that happened in the question. Let's try it again for this one. I go over here. I'm going to open up my graph. I'm just going to delete what we had in here already. Just start from the beginning. And here I do have a new number on the inside, so it's going to be a horizontal change. And here's my new graph. I'm going to push the gear and the table button, and I'm going to put those on paper. Oh, whoopsie. Okay, and here we are. I'm going to see if we could get, we are getting pretty close to the edge of the graph. I'm going to see if we could get 3 and negative 3 on here. We maybe can, maybe can't. So yeah, so 3 is 9, so that's going to fit. And then as you can see, it is symmetrical, so that means negative 3 will also be 9. And there we go. I'm going to connect my dots with a highlighter. Okay, so this one, you can tell it does look narrower. It also moved up. And I'm going to find those changes here in our equation. So our original vertex was 0, 0, because there was no number on the inside, no number on the outside. Our new vertex, there is still no number here. H is right here behind X, and K is right here. So there's still no new number there, so that's still 0. K is now positive 3. So we shifted up 3, and you can see that here we were at 0, 0, and now we're at 0, 3. So I'm going to say shift up 3. And then something else happened. You can see here our original B value was 1 and our new B value is 2. So the number in front attached to X changed. If I look over here, if I'm not sure, I can see what that means. According to our equation here, B is either a horizontal compress or a horizontal stretch, and we can visibly see it got narrower. So it's going to be a horizontal compress because you're pushing in this way, and that's what makes the equation skinnier. So horizontal compress. And then I'm just going to put an X for by, like the word by. A factor of, let's see, our number on the inside was 2, and remember, horizontal changes are always opposite of what they seem. So it's actually going to be technically a factor of 1/2 because you just got to flip it. And there you go. Good. We'll do the same process for the other ones. Here, 3 and 4 were the two that were already done in class for one of the periods, and the other period didn't get to those. So I'm just going to give you, well, I'm gonna do the questions. You pause, so you take as much time as you need, obviously, because you're the one who's gonna push pause. Pause, do these 4 questions, and then come on back when you're ready to check them. Yeah, okay, here are the 4 questions. We got 3, 4, 5, and 6. Just a reminder on the process that we went through with that. I graphed it in the Desmos College Board calculator. I pushed the gear button and then the table button, and I graphed the points onto our graph and then connected the dots with a line. And then over here, I identified the vertex based on H and K. Remember, the vertex is H comma K. It is the center point, so it's wherever the point is, like the actual pointed part. So here on number 3, I'm just going to go through them for all 4 of them. On number 3, H looked like a positive 2, so it actually is negative 2 because the inside is opposite. K was 7, so negative 2, 7, that's right here. On number 4, there was no K, so it stayed at 0. Here, H appears to be negative 3, so it is positive 3, so 3, 0. On number 5, H and K was a positive 4, so it is actually negative 4. K was negative 1. And then on question number 6, here is H and K. Oh, I forgot to label them, sorry. A, B, H, K. There we go. H appears to be negative 2, so it's a positive 2, and K was positive 5. Just remember, the opposite situation only happens on the inside of the absolute value bar, not on the outside. So here's our vertex at 2, 5. And then after that, I just identified all the changes in the numbers, and I wrote it down. So for number 3, we could see H and K change, so that means we shifted down 7. Oh, sorry. We shifted up 7, not down 7. Oopsie. There we go. Okay, so we shifted up 7 to the right 2. So that was here. That's how we got to that dot. We flipped over. You can see we flipped over the x-axis. So that is a vertical reflect. You can see that right there with that negative a. And then it is much narrower. That is because we had a vertical stretch. So we pulled it this way, and that made it skinnier or narrower. And that right here is by a factor of 4. We see that with the a right there. On number 4, we only had 2 changes. We went this way, so to the right 3 spots. You can see that right here from H. And then we had a B value of 1/2. B, so on the inside, remember, it's going to be opposite of what it looks like. That's why I have a by 2, not a by 1/2 right here. And that is a horizontal stretch because it is wider. And I know that because I grabbed it and I stretched it out this way. That's how it got wider. And then same process for number 5 and number 6. Number 5 didn't have any changes in A or B. It stayed exactly the same as it had originally right there. The only changes were it shifted left and down. We can see that here with H and K. And then number 6 had all of them. It had all the changes except for B. So here we moved to the right and we went up. we flipped over right there from that negative sign. And then we had a vertical compress. So we pushed it down like this, and that made it wider by a factor of 1/4. Okay, hopefully that is a good overview for you to understand how to do transformations. Just a reminder, the practice on this is on Delta Math. Now let's actually go to the real lesson today, which is Unit 1, Lesson 7. We did glue this in last time. You have not seen these before. It's still absolute values, but this time we're just going to go over the equations instead of the graphs. We've already looked at the graphs and everything. So at the top here, I just have a reminder for you on what the definition of an absolute value is. So an absolute value is a type of grouping symbol used to indicate a value's distance from 0. This makes everything positive. I put that in quotes, but it's because distance is a positive unit. So we're not actually changing anything to positive. We're just representing a distance, and distance cannot be negative. You can go in a negative direction, but you cannot drive a negative distance. Think of it as if you're driving a car. If you go backwards, let's say you decide you want to drive backwards. I am not saying to do this. This is an unsafe thing. But if you're driving backwards for like 50 miles, you're still using gas, right? You're still going. You're just going in a negative direction. So, and then here, just as we indicate directionality in the negative or positive direction by using left or right. So here I just want to highlight distance from 0. And then I also want you to point out that directionality can be negative or positive. Here, right under that, we have for what value of blank, so insert variable, will the expression, insert absolute value, be insert constant or other absolute value spaces from 0? This is the question we're asking ourselves every time we do an absolute value equation. So we're trying to figure out what value of, let's say, x will make whatever we're given, the equation, a specific space from 0. So we're trying to find a distance from 0. Here it says you can be to the blank in the negative direction or to the blank in the positive direction of 0. You can go left from 0 and be in the negative direction, or you can go right from 0 and be in the positive direction. What I mean by that is, here's a number line. This is 0, this is -10, this is +10. This is the left direction going in the negative direction. This is the right direction going in the positive direction. So -10 is 10 spaces from 0, and +10 is 10 spaces from 0. Both a positive distance from 0. -10 is in the left direction, so it's in the negative direction from 0, and this is in the positive direction from 0. Hopefully that helps a little bit with kind of what we're trying to figure out. Then here we have a space for the steps on how to solve an absolute value, and then we're actually going to start with the questions. So very first thing you're going to do, and we are going to pull a lot of this from just normal equations that you already know how to do. The very first thing you're going to do is undo anything that's happening outside of the absolute value bar. So absolute values are technically a grouping symbol, but they're not done the same way that parentheses or brackets are. You don't distribute anything into it because it's discussing specifically a distance. What you're going to do is get everything from the outside. So treat absolute value bars as if it was a variable that you're trying to get by itself. So we're going to undo everything happening outside the absolute value. Once you've done that, as long as you are set equal to a positive number, then you're going to account for going in different directions. If you were set equal to a negative number, let's say you had the absolute value of x equals -7, that would be asking you for what value of x are you -7 spaces from 0, and that's not possible, right? You can't be a negative distance. So any question where you're set equal to a negative number, it's actually automatically going to be no solution because there is not a way to be a negative distance. You can just be a negative direction. So here on step 2, we're going to assume when we're writing these steps that we're always going to be a positive distance away. So step 2, you're actually going to split your equation in half. So split equation into 2 directions, positive and negative. So that's going to account for if you went to the left or if you went to the right. Step 3, once you've split your equation, you're just going to solve each equation for x. Well, I guess for the variable. It's not always going to be x. And then last but not least, and this part is kind of annoying, I know, you have to check all of your answers to see if they make the original absolute value true. So check all solutions to see if they're true. If you don't do that, you might think that something is an answer, but then when you plug it back in, it doesn't actually work. You can have either no answers at all, so you can have no solutions. You can have one solution, meaning that your distance is actually literally on zero, or you can have two answers. Okay, here we go. Let's look at the first one. Example number 1 says the absolute value of x equals 5. Remember, step 1 is undo everything outside the absolute value. As you can see, I have nothing out here and nothing out here. So this absolute value is already by itself. This is what it looks like for an absolute value to be alone. There's nothing outside of it. And it is equal to a positive number. So what we're asking is, for what value of x, because we're using x here, will the expression, the absolute value of x, be 5 spaces from 0? So we're asking, what value of x is this many spots away from 0? And because it's already solved, like it doesn't have anything on the outside, we would just go to step 2. Step 2 says split equation in 2 directions, positive and negative. So what we're going to do, I'm going to go like this. I'm just going to label L and R for left and right. If I go to the left, I would be going in the negative direction. If I go to the right, I'd be going in the positive direction. For this one, since there's nothing else on the inside, this is just the answer. You don't have to solve anything. So here and here would be our answers. We have x equals -5 and x equals 5 because both of those are 5 spaces from 0 in different directions, obviously. And the way you would check it is you'll just plug it back in. So we would just plug this in here. So it would look like this. And that is true. The absolute value of -5 is 5. So 5 equals 5. That means that this solution works and it is an answer. Same thing you would do here. We plug in our +5. The absolute value of +5 is +5. So 5 equals 5. So this one is also true. And that's how it works. So you have two solutions for number 1. The solutions are -5 and +5. Let's do another one. So let's look at number 2. Number 2 does have stuff on the outside. You can see here there's a number on the outside. So we want to move this number over here. We're going to use normal equation rules. So right now it is multiplying by the absolute value of y. The opposite of multiply is divide. So over on the left, I end up with the absolute value of y. Over on the right, I have -10 divided by 10 is -1. Now here it says, for what value of y will the expression, the absolute value of y, be -1 spaces from 0? Here we're asking to be a negative distance. That is not possible. So there is no solution to this question because it's not possible to be a negative space from 0. So we're going to say no solution because distance can't be negative. And there we go. Okay, let's try another one. Number 3 says the absolute value of w plus 6 minus 5 equals 8. Here we have a -5 outside the absolute value, so we want to move this over here before we can do anything. I have a -5. The opposite of negative or subtracting 5 would be adding 5. I know that because my equation rules. So that leaves me with the absolute value of w plus 6 equals 13. Now you can see the absolute values by itself. There's nothing here and nothing here. So now we can go to the next step. So let's fill in our little sentence here. It says for what value of w is what we're looking for. Will the expression w plus 6 be 13 spaces from 0? So I'm trying to figure out what would I plug in here to make this 13 spots from 0. Remember, we can be in 2 directions from 0. We can go to the left in the negative direction. So it would look like this. W plus 6 is negative 13 spaces from 0 because we're going in the left direction. So again, distance still positive. We're going in the negative direction. And then going in the right direction, which is the positive direction, it'd be W plus 6 is positive 13. And then we just solve each one. So I'm just going to solve for W using normal equation rules. Here I have a plus 6. The opposite is to minus 6. Here I'd end up with negative 19. And then over here I'll do the same thing. And that would give me 7. And then what I'm going to do is just check if they're correct. So you would just plug it back in. So here I have the absolute value of negative 19 plus 6 minus 5 equals 8. And then you just type it into the calculator. And this is the part that gets a little annoying, to be honest with you, because it's a lot of typing. But we're just going to type in the part on the left side. Obviously, we're not going to type in the equals to 8. We want this side to equal 8. So negative 19 plus 6 minus 5. You can see it does equal 8. 8 equals 8. That is true. So this solution works. Then we'll do the same thing for this side. So we're going to plug it in. We had W plus 6 minus 5 equals 8. And then we just type the whole thing in. Sorry, that is an absolute value bar. That looks like a 1. We type the whole thing in the calculator. Actually, I'm just going to click in here and erase my negative 19. That's probably faster. We have 7. And that also gave us 8. So this is also true. That is also a solution. This one has 2 answers, negative 19 and 7. And that's how you do it. Okay, let's look at the next one. Just a reminder, we're following the steps from up at the top. And we have 2, and then in absolute value, we have 6p equals 4. Remember, to start anything, before I can split, I do need to get everything away from the absolute value. I have this 2 out here up front. This is being multiplied. I know that because there's no plus sign or minus sign in between. The opposite of multiply is to divide. And that would give me the absolute value of 6p equals 2. And now I'm going to write down my sentence here. So I'm trying to find what value of p will make this whole absolute value 2 spaces from 0. So for what value of p will the expression, the absolute value of 6p, be 2 spaces from 0? Remember, I'm going to split it between the left side and the right side because distance is always positive, but I can go in a negative direction. The negative direction would be in this way on the left. And then the positive direction would be this way on the right. And now we just solve for p. Here I'm multiplying by 6, so I divide by 6. And I would get p equals negative 1/3. And then over here, still multiplying by 6, still dividing by 6. And I get p equals positive 1/3. Remember, the way that we check it, we do always have to check our answer for these, is we plug our value back in. And I'm going to put it in parentheses here because it is being multiplied. So it looks like that. And then I'll just type that straight into the calculator. I'm going to type the entire thing in up until the equal sign. I have 6 in parentheses. I'm plugging in my negative 1/3. Close parentheses. There we go. And this is equal to 4. Right, so we got 4 equals 4, which is true. So this is a solution. And then we'll do the same thing over here. So I still have my 2 times 6. And then for p on this one, I have positive 1/3. And then we'll plug it in. I'm just going to go back through and change my negative 1/3 to positive 1/3. And it still equals 4. And 4 does equal 4, that's true. So this is also a solution. And that's how it works in general. If you look at the next page, we got a couple more examples. We'll do one more together, and then I'm going to give you a chance to do a couple on your own. Let's do number 5 together as well. This one, remember, first thing we're doing is looking for if there's anything outside our absolute value. There is nothing outside our absolute value, so this is just where we'd start. It says, for what value of v will the expression 3v plus 3 be 18 spaces from 0? Remember, I'm going to split it. For directionality, I'm going to the left, which is the negative direction. And then on the right is the positive direction. Oh, sorry, that's a v, not an x. Z plus 3. plus 18. And then we just solve for v using normal equation rules. So I'm always going to move the constant term first. And I'm always going to divide by any coefficients attached. So on this side, I got -7. And I do the same thing over here. And this time I got +5. But these are my two answers. Remember, what I'm going to do now is plug in my answer. I'm going to put it in parentheses. And then I'm just going to type the whole thing into the calculator. I'm just going to tell you it does give you 18. And that means this is a solution. And then same thing over here. We'll type the entire thing into the calculator. And then we'll see if it equals 18. I'm just going to tell you again, it does in fact equal 18. And that is also a solution. And that's how it works. So see if you can pause, try to do number 6 and number 7, and then unpause when you're ready to check it. Here is 6 and number 7. On number 6, our two answers are -40 and +120. You can see my work here. Just a reminder, we're always going to do the inverse of what's already happening. So we were already subtracting a 20, so the inverse is to add. And then we were already dividing a 2, and the inverse is to multiply. And then here, for number 7, the answer was -26 and +24. Same thing there, just a reminder, we're undoing what's already happening. We were adding a 5, so we inverse subtracted a 5. And then we were multiplying by a 5, so we divided by a 5. Okay, let's look at the next one. This one, I am going to give you time to do it by yourself. But just a reminder, we got to get rid of what's on the outside first. So before you can split up into left and right, you do need to move this 3 over, which is being added. So you would subtract. And then, well, you subtract because it's a positive. But either way, so this one, and then here, this is being multiplied, so you would divide. So work on number 8, and then come back when you're ready. Okay, here's number 8. We should have gotten W equals 2 and W equals 10, both of which are solutions to our equation here. So first we did was move the 3. It was positive, so we subtracted it. And then next we divided by 2, because you're multiplying by 2. And that got us to here. So the absolute value of W minus 6 equals 4. Once your absolute value is by itself, then you can split off into directionality, left and right. So here I have for what values of W would our expression W minus 6 be 4 spaces from 0? Remember, we can be in the left direction, so -4, and the right direction, which is +4. And that got us the 2 and the 10. And then just a reminder, when you're plugging back in to check if your answer is true or not, we plug back into the original equation up here. And I just wrote that right there. And then you just type this whole thing, this part, into the calculator and see if it equals the other side. Okay, now our last 2 here on number 9. This one, I'm just going to tell you, is going to give us only one solution. And that is because when you move this 2 over, it is currently positive, so we would subtract it. I end up with 0 here. So you have the absolute value of G plus 10 equals 0. 0 cannot be a distance from itself. So this says like 0 spaces from 0, right? So for what value of G would G plus 10 be 0 spaces from 0? That means it's literally on 0. So you would just do that. And then just solve for G. And you end up with -10. And then obviously plug it back in. It would look like this. G plus, 2, 2 plus absolute value of -10 plus 10 equals 2. Plug this into the calculator and you would get 2 equals 2 because it's true. So that's what it looks like if you have only one solution. And then number 10 is what it looks like if you have no solution. So here we do have a number on the outside. This is a -1. Remember, if there's not a 1 there, it's implied. So we would want to divide both sides by -1 because it's currently being multiplied. And when I do that, I end up with the absolute value of P minus, sorry, my brain wanted to do plus, 20 equals -1. So here we're looking for the the value of P, where the expression P minus 20 will be -1 spaces from 0. But remember, you can't be a negative distance, so this one doesn't work. So we would say no solution because distance can't be negative. Let me just write the word. It looks weird to have just the sign there. Okay. And there we go. So here's a good little example of 2 solutions, 1 solution, and no solutions. Good. And that's it. I hope this helped. Just a reminder, we're just following normal equation rules. They're in the very first page of your journal if you need help with that, the steps. And then we're always going to double check our answer using the calculator to make sure that our solutions are true. Perfect. Hope this helps. Have a wonderful day, and I'll see you later. Bye.